All right, here we go with significant figures. This is not everybody's favorite, but we will make it through. The term significant figures refers to digits that were measured. Because in the lab we use equipment and instruments that have differing amounts of precision, we have to include significant figures in our calculations. So when we're rounding calculated numbers, we have to pay attention to significant figures so that we do not overstate the accuracy of our answers. Say our volume was 25 milliliters. We can't say it was 25.000 milliliters because that's not how precise our equipment was. We need to pay attention so that people know how accurate the equipment was that we were using. Well, how do you know what a significant figure is? If you look at these, here are the rules. Pause it, write it down. There are 3 types of zeros. And that is what we're going to get to in 1 second, but those are the ones that cause people all the problems. It's really easy to know that all non-zero numbers are significant. So 1 through 9, all of those count as significant all the time, no matter what. You have your leading zeros. So leading zeros, let's just make up a number here that has all the different types that we're talking about. All right, so I have 0.007090. Leading zeros. Leading zeros are the ones that come in front. They lead the number out. These do not count as significant. They do not matter. They're just placeholders. Trailing zeros. That's this guy at the end. Any zeros that come after the last non-zero. So this one would be significant because it says trailing zeros are significant only when there's a decimal point. There's a decimal point right there. So this 0 would be significant. And then your captive zeros. So your captive zeros are in between 2 non-zero numbers. So this one is also significant. If we were wanting to count these, then we would say that this number has 1, 2, 3, 4 significant figures. And we're going to do lots and lots of practice with this. And the last one is exact numbers. So for example, if I said I had 3 apples, and I'm using that in a calculation, because I counted the 3 apples, it has an infinite number of significant figures, so it doesn't count. It doesn't get included. We just kind of ignore them. So this one is asking us to determine the number of significant figures in each measurement. So if we look at these, we have 508.0. Well, captive zeros we know always count, and this trailing 0 could be tricky. It does count if there's a decimal, and there is. So significant figures in this number would be 4. Significant figures in this number, we have a captive 0, which will count, and so do all your non-zeros numbers. But then we have to look at our trailing zeros. And our trailing zeros are only significant if there is a decimal, and there is. So that means all of these numbers are significant. So we'd have 1, 2, 3, 4, 5, 6, 7 sig figs. Just because this is written in scientific notation, don't let it throw you for a loop. You ignore this times 10 part when we're looking at significant figures. So just ignore. We look at the part that comes before it. We have a captive 0 which counts, and our trailing zeros count because there's a decimal. So that number would have 1, 2, 3, 4, 5 significant figures. In this number we have leading zeros, and we said that leading zeros never count no matter what, even if there's a decimal. So no, 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 which means only my 8 and 4 are significant. So just 2 sig figs. Here we have 807,000. I have a captive 0 which counts. My trailing zeros in this number, however, do not count because there is not a decimal. So you don't count, you don't count, you don't count, which means I have only 3 sig figs. Here we are again, Avogadro's number. We ignore times 10 to the 23rd. We look at just this, and with only 1 captive 0, this would have 3 sig figs. And again, we have leading zeros. We always ignore, and I just have the 4, 5, and 6 at the end, so this one would also have 3 significant figures. Alright, so we're going to try something a little different. We're going to try and round to 4 significant figures. So I have 84,791. I only want to have 4 significant figures. What that means is I need to make this one not significant. And in order to do that, I look at the 9 or what comes after it, but if I make that a 0, I know it's not going to count because there is no decimal. So if I make this number 84790, then I only have 4 significant figures. So that would be the correct way to do that one. All right, I need to have 4 sig figs here, which basically means I need to cut off the decimals right there. And since this is 32, just like in regular rounding rules in math, 32 will not round the 4 up, so that's just going to stay a 4, so I'd have 38.54, and that would be my 4 significant figures. Here, we're going to want to cut the number off right before the 6, and that 6 is greater than 5, so it is going to round our 7 up. So we'll have 256.8 for our number. 4.9356, again, I need to get rid of some of those decimal numbers, and that 6 will round up that 5, so 4.936. 2.0145, I want to cut the number off right there. In general, a rule for the 5s is if you have a 5, you want to keep the number even. So since this 4 is an even number, I'm not going to change it. I'm going to say that that 5 doesn't affect it. If it were a 3, then I would round it up. And that kind of makes it go 50-50. If you try to keep the number even, you end up rounding about half the time. So that's how I'm going to deal with 5s. And then I have 8,095.23. Well, if I round to 4 significant figures, I don't want any decimal places. So 23 is not going to cause this guy to round up, and that means it's just going to stay at 8,095. And that's it. So make sure that you wrote down the rules on what's significant and what isn't, and we're going to do lots of practice with this in class.